Hello, students.
Hello, good afternoon,
Good
sir.
afternoon,
Good afternoon,
sir.
sir.
Good afternoon, sir.
Screen is
Good
visible, na?
afternoon, sir. Yes,
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 sir.
sir.
Yes,
Yes, sir. Yes.
Okay. So now I will start the lecture. I have completed this all this now. We will discuss today. As we have discussed this manometer basically. What is this piezometer, manometer, and the different types of manometer like differential manometer, U-tube manometer, and single column inverted tube manometer. Inverted tube means the tube will be inverted in the upward direction. And also we have discussed this modern gas. Okay, now today we will discuss this part, the hydrostatic force basically. So hydrostatic force, we are already aware of this. What is this hydrostatic force? Okay, means this is the basically the basic expression for the force. Here what you need, just need to put the equation of the pressure. That is here it is del P by del Z is equal to rho G. So you need to put this here. When you will multiply here dz, it will come out here rho Z into dz. Okay, and here we need to integrate this. When you will integrate this, you will come out the ultimately what is the pressure acting at a particular height like this, at a particular height. So this will be your hydrostatic force. This we know. And it is the summation of the product of uniform pressure and elementary areas of the submerged body. Means the uniform pressure means if your there is, if there is no further variations or disturbance in the fluid, so it will be like, because it is a static, so that's why it is considered. So your pressure is basically like the means the force is like the pressure into area. So basically, as we told that this is the pressure force. So this name is called the pressure force. The force exerted by the press. Okay. Now there comes a certain things like what is the value of this total pressure at a certain height for the different cases. What are the different cases? We are going to discuss this today. Okay, and what are these applications that we will also discuss, and also the point means the point where this will act means the total pressure inside the body. Okay, what I am
Sir, you are not audible.
सर क्लास में ही है।
लगता है कोई नेटवर्क इशू है, प्लीज ऑन करेंगे।
Hello students, am I audible?
Yes, sir, you are.
Yes, sir.
Yes, sir. You are.
Connection कब गई बच्चा ये कनेक्शन? आपने क्या लास्ट क्या सुना था, जरा मुझे बताना।
सर हाइड्रोस्टेटिक।
आपको लास्ट क्या याद है इसमें? मैंने क्या बोला था लास्ट लाइन आप लोग जो सुन पाए थे? जस्ट टेल मी द लास्ट सेंटेंस।
Sir, you are just saying the definition of that hydraulic pressure.
Yes,
डेफिनेशन ऑफ हाइड्रोस्टैटिक फोर्स उस टाइम से ही गई है ये।
Yes, sir.
yes, sir.
वही डिस्कस कर रहे थे,
दूसरी
बता
चीज पे
बता।
चला गया। चलो कोई नहीं।
सर एक बार फिर से ही बता दीजिए, फिर शुरू से कंसिस्टेंसी।
Is it feasible?
Yes, sir. It's visible.
पता नहीं ये कब कनेक्शंस चले जाते हैं, कभी कभी पता भी नहीं चलता है। Okay, so hydrostatic force means the force which is exerted due to the height of the fluid way above the surface, means the forces on the immersed bodies. So look here, this is your immersed bodies. So what is the forces acting on this surface due to the fluid which is above this surface? And that fluid is in the static condition because this is a static, hydrostatics. Okay. So that is called the hydrostatic force. The equation we have already discussed, that is P is equal to. So it will ultimately come out like pressure into area will give you the hydrostatic force. Okay. So it is just like the summation of product of uniform pressure and the elementary area. So this is the definition of basically hydrostatic. So that we are familiar. But the important point is this in this topic, we are going to find out this basically, I mean the total, what is the total pressure acting on this in bodies, on this type of bodies, which is immersed in the fluid basically. Okay, and where this force is acting. This is our concept. So this we are going to discuss. The total pressure means the expression of this total force. This we have to discuss the expression. And the point where this force, the total force will act, that is called the center of pressure. Okay, that is called the center of pressure, the point where this total force will act in the body. Okay, am I audible?
Yes, sir.
Okay.
Yes, sir.
Okay, now as I told you that it is a topic related to force acting on immersed bodies. So we have some classification of these surfaces. So what are that? That is vertical, horizontal. Okay. Then the curved body, horizontally immersed curved body. So this is the curved bodies, and this is the inclined bodies. Okay. So first let me clear out that vertical body means when we have the height. Okay. When we have the height, like let me show you. Let us suppose I have the space. Okay. If I am holding with this, anyone can tell me Is there any height?
No, sir.
Now, what is this? Is there any height?
Yes, sir.
Okay, so this height variation can generate the pressure at the different points, the different pressure at the different points. So this is the vertical case and this is the horizontal case. Okay, and this is your inclined case when your body is like this. Okay, and when you will form this like this, sometimes what happens, we have a curved surface also like this. So this is like the curved surface. So these are the things, means these are the different types of bodies, okay, which generally occur in the practical application, and that this is what we are going to discuss. Okay, so first, in which there is a height. Curved means there is a horizontal and vertical both component. You can, that we will discuss. This is the inclined, means this is the, actually you can say the vertical and horizontal is a case of inclined basically. Okay, so let us first the finding the equation for the force. What is the expression for the force basically? Okay. So let me discuss that. Okay. Now here let us consider this is our body. Okay, this is our body. And I am taking, okay, here I am taking the example of that incline basically. And from the incline, we can easily discuss the horizontal and vertical. Okay, so first we are going to discuss the incline, and vertical is a special case of incline. Horizontal is also, you can say, the special case of that incline. Okay, so it is better to discuss one, that is incline. So this is the inclined body here, which is making angle theta here. Look at this. Okay, so look at this. This is our inclined body. So this is actually the body that I have drawn for the convenience that this is our body. And obviously there is a fluid above this body. These are the fluid areas. Means these are the fluid area. Means this body is inside a fluid. Now this is actually the h, means the height. H is the vertical height, and y is the inclined height from this axis. If you are drawing any axis from this surface, okay, which is perpendicular to this surface, look at there, this. Okay, so this is actually y, which is the height, means the distance from this axis, that is ox. You can say it is ox, and that ox is perpendicular to the surface of the body. Actually this is perpendicular, look at here. Okay, so there is a two distance, that is h, which is vertical distance vertically from the surface, and y, which is inclined distance from the axis ox. And what is that ox? I think it is clear now. Now first the relation between these. Yes, if you will draw here, we are taking here a elementary part. Look at here, this here we have a elementary part here. Okay, so we are taking this elementary part here, means the projection of this here. Okay, now look at this. Let's draw here a triangle. So this is our triangle, like A, like B, like C. So if I will draw this here like A, B and C, so this is our actually H, and this is our Y, this is our theta. So here obviously the relationship between HY and theta is Y sine theta. So look at here, this is H is equal to Y sine theta. Okay, so these are the like the inclined depth here, all these things are mentioned here, that is elementary area. This figure is also saying the same thing. Look at here, that is vertical distance, and this HP is the distance of the total pressure, means this P point is considered the point where the total pressure will act, which is here, and here it is this CP, and this C point is the centroid of the body, which is at a distance YC, and the pressure is at a distance YP from this OX axis, and centroid is at a distance YC from the OX axis, and y is the distance for any elementary area. Like here, we have taken. Let me erase this actually. Then it will be clear to you. Okay. So this is your elementary area. We are going to choose this elementary area, and then we will do our exercise for find out the total expression for total force and center of pressure. Okay. So this is the distance where this elementary area lies, that is y. And correspondingly, you can change this distance, this inclined distance, in the terms of h. Like here, look at this. That is your HC. That is your HP. So obviously, HC will be equal to SC sine theta, and HP, which is the point for the total pressure, will be like YP sine theta. Okay, like here we have the value that is YP. Okay, so these are the relations. So we have the two distance, one from the vertical and one from the incline, and these are the relations. So this you have to kept in your mind for the further operation. Okay, now let's choose this diagram. Okay, now what is the pressure acting on this body, the elementary body? What I am talking is for the elementary part here. That is P. Obviously, the pressure will act on this body into area. So what is the expression for this pressure? We know that P is equal to, that is rho Z into H. So we can write down this as gamma into Z. So here, okay, that gamma actually we have taken here. Okay, in the terms means like that gamma is basically rho Z. Okay, rho here it is rho Z, that gamma. Okay, so look at here, when you will add this will give you this pressure here. When you put this, it will come out the expression. Now let's change this H in the terms of y by using this, as I have already discussed this relation. Now put this expression here and integrate for finding the pressure over the entire body, means over this entire body. For finding the pressure on the entire body, obviously we have to do the integration. When you will do the integration, you will come out with this expression. Okay, just substitute all these relation here in this expression at the place of H, at the place of this. Okay, gamma is same here. Okay, no need to change this gamma. Now this gamma is basically, that is density and gravity. So these two are the constants. So obviously this will be come out of the integration sign. Also this theta is fixed. If it is fixed, if it is not changing, then it obviously it will be fixed. So this can also be out. So we have this under the integration sign. We have this under the integration sign. Now let me tell you what is this. If you have studied, then you will tell what is this. This relation, what is this actually? Who will answer? Am I audible?
Yes, so you're
Yes.
audible.
So what is this? Who will tell me? Asutosh is there?
Yes, sir.
Tell me what is this?
The
Agar
movement of area.
only moment?
The movement of area.
Or not only moment. First moment of area. If you remember, there is a two, that is first moment and second moment of area. Remember my class. Okay, so
Yes.
this you can write down this, that is first moment of area. Now remember your the class of centroid. I think all of you have studied this in the subject EME. In the section of centroid, means in the chapter, that is centroid, this relation, that is first moment of inertia. I don't know about the mechanical branch because I have not taught you. So this is, so that's why I'm informing you that this is the first moment of area. Okay, means this is the relation. With the help of this, you can find out the center point, the centroid point, sorry, centroid point. Okay, if you remember, so this is your center of gravity. If the gravitational force is parallel and equal, then centroid and center of gravity lie at the same point. Okay, so this is your first moment of area. So in the place of this, what happens? We need to put this, that is centroid point. So this is actually the centroid points. When you will divide this, okay, when you will divide this with that AC into AC, it will come out with like this. That is centroid point, that is YC into AC. So this ultimately, this is, we can write down, that is YC is equal to IC when you will divide this with area. So this will give you this relation here. So this is, when you will substitute this will give you an expression for finding the total pressure. That is actually it is very easy, means there is no hard work in the derivation actually. Sometimes derivation comes in the exam actually. Okay. Now, where YC is the distance OX along the sloping plane of the centroid. Now, the question is, what is YC? Look at here, your YC is actually the distance of the centroid point from this axis. Okay, means your total pressure is depend on this YC value. Okay, means if your body vertical height, let us suppose your body vertical height is this, and in the another your body is here. So if this is 5 meter and if this is 7 meter, so what is the difference here? If it is vertical, so it will act like 2.5 meter, the centroid. Here it will act at the 3.5 meter. Look at the difference. Means the pressure will act here and the pressure will be more in the case of this type of body whose height is large. Okay, so this YC defines what will be the force, the total force will act on that body. And in the short, you can means in the form of H, because we have the expression for this, that is H is equal to YC into sine theta. So you can substitute this. Look at here, we have the YC. Let me erase this. What happens here? Okay, so now let me erase this formula. Okay, so carefully look at this expression. We have sine theta and YC. Here actually this C is here, it is actually here. Okay, so we can replace this YC sine theta with HC. What is HC? It is the vertical distance, this vertical distance from the free surface, the vertically downward. This is not the vertically downward, this is inclined, and this H is the vertically downward. So if you have the value of this, you can also find out the total force acting on the body, means the vertically downward distance. Okay. Now the next is to find out the center, means where this force will act. The question is where this force will act. Okay, is the screen visible? Hello.
Yes, sir.
Okay.
Yes.
So this is actually, this is the same thing, but here one more important point to discuss, that during finding this total force on any plane area, okay, multiplying just simply the specific weight. This is your specific weight, this gamma is the specific weight, and just multiply with the vertical height. Okay, and the area. So obviously the area of the bodies you already know, because you know that what bodies you are going to use in your application. Okay, and also you are very much aware of the fluid, and it is only the H which we need to decide, that what is the appropriate H to maintain a static condition, so that your system will not collapse or damage. So this is the key point, that just find out the H actually in the static. So in all the static condition, if you remember the class, the first class till date, you will find that all the times it is only the game of this H. So all the time, what you need to find all the time, H. So H is very important in the static case. Okay, and F is independent of the inclination of angle. Look at here. Actually, it was inclination, but in the expression, there is no such type of inclination. So it is free from the inclination. So whatever the inclination, okay, you can say that the force will be. Okay, so this is one of the important. And this is since gamma S is the pressure at the center, so we can also say that a total pressure for any plane submerged is liquid is the product of area and pressure, that we know. Okay. Now the next is center of pressure, means how we can find out the center of pressure. For finding the center of pressure, it's very simple. Now look at this. Let me give you the example of the vertical because it will clear you the picture more accurately than this vertical. Okay. So just let me take this. Obviously, if there is a fluid, okay, if there is a fluid behind this body, just try to understand. Okay, let us suppose, obviously, this is the fluid actually. This dot line is the fluid. Okay. So obviously, due to this height, there will be a pressure force will act. Let us suppose it is acting here like this. This is your pressure force, that is Fp, which is generating due to this height of the fluid. Okay. Now look at here. Obviously, there will be, if this is the distance, and if I ask to find out the moment about this, then obviously you can find out this moment. So means I mean to say there is some moment effect inside this body. So how you can find out this moment? So look at here. This is your force. This Fp is the force acting here. Take the moment about this point. So that is moment, that is y into df. Just take a elementary area and the distance for finding is that is y. Again, if I am taking y, means like this. Just take a y. Okay, and take the moment. Just put the expression for this force like pressure into area, and we have derived this expression. Look at here, that is P into D. Here we have the expression now, so we can utilize this actually. This is our expression. Okay, substitute this here. This gamma Hg is actually the pressure. That gamma Hg is actually the pressure. Okay, so here we are substituting this gamma Hg, and we know that the relation for H is equal to y sine theta. So in the terms of y, it is y sine theta. Okay, now what we need to do, we need to integrate this. We need to integrate this. So just integrate this moment. Integrate this here. Again, these are the constant. As we have did earlier, we have already discussed that gamma, that is rho g, is the constant. So what we have now, it is only this term, that is y, because we know that the y varies. Look at here, this y is varies. So we have to do the integration of this. And here, if y varies, then area will also varies. Like here, you can take dy into any width, just take a unit here. Ultimately, okay, tell me what does this expression shows here? Y square into dA. What this showing? Who will tell? Who will tell? What is this? Asutosh. Am I audible?
Yes, sir. Yes, sir.
Now what is this?
The first moment of area.
That first moment. It is second moment of area, and which is basically the inertia. Now look this equation carefully. कभी यूज किए थे इसको एग्जाम में? This
Yes,
time
sir.
it is second moment of area, which is also called the inertia. Moment of inertia. आपने कितनी बार आप लोगों ने, I think so many times we have used this. Okay, this moment of inertia. So this term y square into dA is actually the moment of inertia, which is also called the second moment, okay, of area. So here this will a term will come, that is second moment of area, means the moment of inertia. So you have to find out the moment of inertia. Now this you have to find out the expression for this yp, because this yp is our distance of center of pressure. Now we have the expression for this fr. If you remember, we have a fr we have already derived here. So what we need to do is just substitute fr here. Sorry, where is the, yes, we need to substitute fr here. Let me erase this. Then you will come out with the expression for this. So just substitute here, okay, at the place of this is actually fr. So fr is gamma yc sine theta a, that we have already derived. So here you can see that this sine theta, it will be cancelled out, and that gamma will also cancel out. Okay, so what we will have that moment of inertia divided by this yc and this area. So that is yc by area. So this is the expression, means that yp is actually equal to y by yc into area. So this will give you that yp. Okay. Again, if you will use the parallel axis theorem. So what parallel axis theorem says, that this is the centroid plus the distance between the axis and the centroid, the area into the distance, that is yc square. So this is your axis and this is the centroid. So this yc is the distance. So area times the square of the distance between the axis and the centroid point. So this is your, now substitute this here in this equation at the place of I. So ultimately you will come out with this. Now what is this IC? IC is the moment of inertia about centroid, about this point, this centroid point, this point. Okay. Clear? Now, when we will do the separate work here, so that will come out the first term, that is IC by YC by A, and the second term here, look at here, YY will be cancelled out and one Y here will be cancelled out. So there will be only one YC. So this is your final expression for finding the moment of, the center of pressure. In the terms of H, we know that H is equal to, that we just need to use that sine theta, like at H is equal to YC sine theta. So here you need to put this at the place of, at every place here. Now, as I told you, that the vertical case is an example or is a special case of this incline. So now, for making body vertical, what will be the angle of this theta? It will be 90 degree. When it will be 90 degree, look at here, this will be the case of vertical. So what we need to do, we need to substitute this theta here. So if this is theta, then YC is simply equal to HC. Just put sine theta means the sine 90 is equal to 1. So it will come out YC is equal to HC. So just look at here, your HP will be equal to, YP will be equal to HP, YC equal to HC. Okay, so this is the expression for the vertical case and this is the expression for the inclined case. Now what is the relationship between the vertical and inclined is this, that Y is equal to H sine theta. So by putting this, you will come out, you will do the inclined and you can also do the vertical. So this is the case for the, okay. Any question? Am I audible? Students, am I audible?
Yes, sir.
Yes,
Yes,
Yes.
sir.
yes, sir, you are audible.
Can we move further, or if you have any query? Means if you have any query? No? Okay. Then moving to the next that is means the horizontal case. Okay, as I told you. Okay, that horizontal means if we take this example. Okay, means this example that this in this case actually when you will put this, okay, this your sine theta here, the sine theta will be equal to 0. Actually, this case represent means, let me discuss the simple technique. We don't have this height in this body. So it means that this in the vertical case, this is our, let us take the vertical, that is HC and HP. If there is no height variation, then what will happen? Then this HP will be equal to HC. Okay, if you will go with this, then you will find this type of condition here, that this HP is actually equal to HC. So this is actually a case when the centroid, means this is the case actually when centroid and the center of pressure coincide, because there is no variation in the height. So obviously the point, these 2 points will be coincide at the same vertical height, remember, same vertical height. So that's why there is no need to develop any other expression for finding the center of pressure, because the center of pressure and center of centroid will act at the same point. Okay, and also the expression for total pressure will be same. That expression will be same, but the only need to understand here that these 2 points, that HC and HP is coincide here, because there is no variation in the heights. Okay. So that's why there is no need to develop any other lesson, because we don't have the height actually with the variation. Now we have a certain body is which you need to apply this, mean that is mean these are the body which you will observe during the numerical solution, and these are the corresponding like the area and the moment of inertia. I think you have already used these relations. Okay, but here in this static chapter you are again going to use this moment of inertia, because here we have the moment of inertia in the expression. So you will require this during numerical solution. Okay. We have another problem, means another surface which is called the curved surface. Get here. This is our curved surface. There is no need to derive again the further expression actually. It is the case means, because we know that this pressure is a normal force. Obviously it will act normal here. Okay, let us suppose that it is making angle alpha with this. Okay, either this, you can take any angle. Okay, so obviously there will be the 2 component of this, that is horizontal component and the vertical component. Okay, so the vertical component means the horizontal component. Okay, first of all, we can't do the integration because this is varying, it is not linear type. Okay, it is like the curved surface. That means your curved surface can be any shape, like here you can see. So simply you can't means the integrate, because this is a curved surface. It can be any shape, not a regular shape. So integration is not here. So what happens in this case means, for this pressure actually, we need to take this PH and PV, means the horizontal and the vertical force. So horizontal means we need to take the projection of this on this vertical height like this. So when you will take the projection, so it will give you a pressure force on this vertical face, and this vertical face is actually the projection of this AB curved surface. So by using this, again the concept will be same, that is the pressure which act on this surface, that vertical surface. Okay, that you just again we will go back for the vertical case. Now the next is how to find out this RH. So RH is actually means, sorry, not the RH. RH is this. Okay. Now next is the vertical. The vertical actually developed is due to the weight which is above the plate. Means this vertical component is actually the weight of the fluid vertically above AB. So what we here we need to find out this weight actually. So when you will have this RH and RV, we need to use the resultant force. So this will give you the resultant, and by doing this, you will come out with the angle. So here one more point is added, which is the vertical component. Means the vertical component of this force which is acting, means the pressure which is acting here. So this means how this vertical component is generating, it is due to the weight above. So here comes the two pictures. One, the pressure force which will act on this surface, and one will act on this BC face. So these are the two components. Okay. Now let me show you some another thing. Okay, if I will give you, okay, I want to discuss what is the need. Let me, yes, this page is here. It is. Now the application of this static is in the dam. So look at here. This is our dam actually. Okay. What happens? Why we need the static? Okay. I think all of you are aware of the dam right now. सभी लोग जानते हैं ना? Hello, just confirm me.
Yes, sir.
Okay, so all of you
Yes,
are
sir.
aware of this dam, and we know that behind this dam we store the water. There are different purposes of storing this water. Sometimes we store the water. Actually we develop a height. So for developing a height, it means initially your fluid is flowing with this height. Okay, but with this height, your turbine not works because dam is actually installed at a location where we need to develop a hydropower for the electricity. And with the help of this pressure force, okay, because when we'll develop this dam, a height will raise in this fluid. So when height will raise, obviously now you have the idea that pressure will varies, and we know that the pressure at this means below, means with the height, with the depth, the pressure increases. So always you will find that the shape of the dam is this. Here you will find that it is very thick at this bottom level because the maximum weight is supposed to concentrate at this point, because we know that when it is this type of triangular type of shape, your like the centroid, where centroid at it is, that is 2/3 from the apex. So that's why we develop this type of shape, so that our objective is to take the weight at the bottom of the dam. Because why bottom? Because there is a high pressure at the bottom, because it increases with the depth. Now let us suppose that the pressure which is acting with due to this fluid is more than the weight of the dam. Then what will happen? It means there will be two moments. One which will try to topple this, means overturning this dam. So sometimes you will hear that the dam is failed. Why it fails actually? So it fails due to this, like if your pressure will be very large, then it will start topple from the bottom like this. If this is your X, so it will start rising because the pressure will act on the, means this pressure will try to rotate this dam. Because if you are considering this is the point, because it will rotate, your dam will rotate about this point, about this point, about this point. It will start like toppling like this. So this is the point where you need to take the moment. So let us this, if this is the this is the distance, that is h. So what will be the moment? It is f into h. So it will be like in this direction. Obviously, you will need a resisting moment in this direction. Okay, so this is like the resisting moment, and this is like the overturning moment, OM and RM. So obviously this RM should be large. How you will find out this RM? So that RM is totally depend on the weight of the dam, because this pressure force is balanced by this weight of the dam. And we know that this is like the rectangle and triangle. So RM you can find out means this should be, this is actually the OM and this should be equal to RM. Now RM is actually, if you will take this part, the weight is W1 and the weight of the triangular part is W2, and you need to take the moment about this point. So look at here, we need to find out the first of all where this weight will act. Obviously it will act at some point here from this, that is 2/3 from this. If this is the total, if let us suppose this is your H1, so 2/3 this, so this will generate like W2 into 2/3 into H1. Now here it will act at mid of this, so that is 2/3 H1 plus this height also, if you have this length like H2. So this will be like plus W1, okay, into 2/3, and this is actually not 2/3, this is like actually that we need to do exercise, that is H1 minus this. So this is not 2/3 here, it will be like H1 minus H2/2. So this will give you the resisting moments, and for the equilibrium, this resisting moment should be greater than this. What happens sometimes during the flood, the height of the fluid goes very high, and due to which this force, this FP force is very large, means it is so large that RM is very close to that OM, and your dam will fail. Because with the flood, actually what happens in the flood, there is a turbulent effect also. So if you will reach equal to or even a smaller, then other effect is like turbulent, because we know during the flood the fluid is in a turbulent motion. That turbulent is also a fact. So that's why what actually our objective during the building of this type of dam, that we need to cap this, means the ratio of this RM and OM should be like the 5 times. Okay, so based on this we design this dam. Okay, so this is our like factor of safety, like 5, this can be 7. So if this 5 means this, if this number is increasing, the weight of the dam will increase. Clear? Hello students, any question? Am I audible?
Yes, sir, you're audible, sir.
Yes, sir.
Yes, sir.
समझ में आ रही है
Yes,
ये?
sir, you are totally audible. Yes,
समझ
sir,
में
yes,
आई
sir.
है?
Yes, sir. Yes, sir.
डैम
Yes, sir.
डैम में बेसिकली हम लोग क्या कंसीडर करते हैं? हेलो, कुछ बोल ही नहीं रहा कोई। ये जो बताए वो समझ में आया या नहीं आया? कुछ नहीं बोलते, पता नहीं सुनते हो जी आप लोग? हेलो स्टूडेंट्स,
Yes, sir.
Yes,
sir.
सभी को समझ में आ रहा है ये?
हाँ
हाँ,
सर,
sir.
वो आज थोड़ा सबका सुबह से क्लासेस में।
Okay, let me show you, let me present a screen actually. I will show you something. Which screen is visible right now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, is this screen visible?
Yes, sir.
Yes, sir.
Yes.
Okay, I am playing a diagram here, basically for the clearance of this dam actually. Okay. So you can see the example here, why we need the dam and what is the role of this dam actually. Actually, the water flowing through this section. Are you able to see this arrow?
yes, sir.
Yes, sir.
Yes, sir.
Okay, so this is actually called the penstock, and with the help of this penstock, we direct the fluid, okay, towards the turbine, and this is our dam height. Okay, so what happens below this means at the lower portion, we do not have the enough potential energy. So what we do, we develop a dam, means we raise the height of this fluid. up to a good level. Means it is that level which is depend on your generation, the power generation. Means how much amount of power you are going to generate. ये सारी टास्क हमें हाइड्रो पावर प्लांट सेट करने से पहले करनी होती है कि कितनी अमाउंट चाहिए, उतनी के लिए हमें इतना पोटेंशियल एनर्जी चाहिए, उतनी एनर्जी रहेगी तो टरबाइन कितनी स्पीड से घूमेगी, करस्पॉन्डिंगली हमें उतनी पावर मिलेगी. So like this, so that is the basically the example of this static, and here we apply all the static conditions. Okay, जैसे मैंने, so this is the example where we need to apply all the concepts of this statics. So you can see here that how the turbines, okay, rotate basically. So this is the turbine installed at the lower portion. Okay, clear? This is our turbine house. This is called the turbine house, and this is the pen store. समझ गए सभी?
Yes.
Sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so this is your example. Means this is basically the, means you can say the application where the statics condition hold very good. And as I have discussed that what is the basically the required concepts during the construction of the dam. So we required the amount of the force, means the height basically corresponding to that height we find out the force, and then we take the moment, and according to that we set a factor of safety कि हमें कितनी times उस प्रेशर से ज्यादा हमें वेट रखने हैं. जितना टाइम्स आप वेट ज्यादा रखोगे उतनी आप सेफ हो. बट आफ्टर सर्टेन लिमिट है ना, आपको फिर नहीं होती है कि ठीक है आप लाइक अब 20 टाइम्स जाओगे, डैम काफी बड़े होते हैं इस तक. सो उसके बाद फिर फायदे भी ऐसे है नहीं. सो एक लिमिट है कि कितनी हमारे पास हाइट बढ़ सकती है, हाउ मच हाइट. Okay, in a worst condition like in a flood, basically the main threat of dam is flood. So during the flood, okay, means by considering the flood situation in your country or for a particular location, because आप लोग observe करते हो कि you can observe this, okay, actually in this raining season कई सारी जगहों पर अभी flooded cases हैं और कई सारे डैम्स जो है फुल हो चुके हैं. Now there comes a sluice gate, okay, which helps to release the water in the worst case. Suppose dam में बहुत ज्यादा height पानी होगी and now there is a very much turbulence. So what happens? We open the gate. Now during the open of gate, now again we require the static condition, that what much of force we required to apply for opening of the sluice gate, because at the bottom there is a gate to release the water. Okay, during in such type of situation, during the flood situations. So again, during the opening of the sluice gate, we required again a status, because there is a force and we have to open the gate against that force. So that's why we required again the statics. That means the moment. Again by moment, you will come out with the value that this amount of force we need to apply on your sluice gate to open the gate. Because I think every year when there is a rise in the height, your dam is open. I think बहुत लोगों ने ये देखे भी होंगे, अगर किसी की घर डैम के आसपास है, I think so they are very much familiar. Now that students can understand what is the role of the dam and the sluice gate and the statics condition, and what are the different situations we need to consider during the building of the construction, means the dam construction. Okay. Now I will take the attendance because we are running late actually. But it's okay, we have. Okay, Aviles, Ajay, Abhishek, Jangir, absent. Okay, Abhishek, Ajay Bharti is present. Before the Ajay Bharti, all are absent. Ajit Singh is present. Akash Yadav present. Amandeep present. Amar Bhardwaj present. Amit, Aniket, Anand Jain absent. Aniket present. Anirudh absent. Anjali Meena. Aniket Kathuria. Aniket कथूरी आपके
Yes,
रोल
sir.
नंबर क्या है, सर?
14 roll number, sir.
ओके आपकी तो होगी, ओके ओके ओके।
Sir, I also want to say, sir, roll number 3 and roll number 15 have changed their branches.
हाँ मुझे उसका पता चला है। इट्स अमित आई थिंक थर्ड चेंज ना, अभिषेक थर्ड ना।
Yes, sir, yes.
ठीक है, अभिषेक थर्ड, ठीक है। अंकित, आनंद, अर्चित इज एब्सेंट, अंकित और अर्जुन इज प्रेजेंट, अर्षित इज प्रेजेंट, आर्यन इज प्रेजेंट, आशीष, आशुतोष, अतुल, आयुष, आयुषी, चैतन्य एब्सेंट, चरण एब्सेंट, भुवन गर्ग
प्रेजेंट सर, चरण प्रेजेंट।
कौन? ओके चरण इज प्रेजेंट। ओके बीच में ये अपग्रेडेड की 2 रोल नंबर आ गई ना, भुवन, ओके ओके। चैतन्य इज आल्सो प्रेजेंट देन, डेविड प्रेजेंट, देव is present, Deepnan absent. Ticket Aniket, are you there?
Yes, sir. Present.
Okay. Deepnan, Devashish is present, Satvik is present, Gagandeep is present, Gaurav is present, Geetika is present, Gurmukh is present, Hari Jai Singh is present, Harish is present, Harmeet is present. Okay, Harsh Bajaj is present, Harshit is
Yes.
present. Okay, Hemant Joshi present, Imani is present, Inayat present, Ishu Bhagat. No, Jashandeep, JV Reddy, Jashandeep, Karanveer is okay. Karandeep, Siddhi is present, Laksh, Hare, Harish is present, Lokesh is present, Manisha.
Present, sir.
Okay, Mansoor, Danish, Mohit, Narendra, Raman Gupta. No. Narendra is present, Naresh is present, Naresh Singh Rawat.
Yes, sir.
Okay, present.
Present, sir.
Okay. Nodeep, no. Neeraj is present, Nikhil Kumar, no. Nikita, yes, Nodeep, अभी आया, ठीक है।
सर वो माइक नहीं चल रहा।
ठीक है, निकिता इज प्रेजेंट, नीलेश इज प्रेजेंट, नितेश, नितिन, मीना अगेन एब्सेंट। ओके, नितेश सोलंकी प्रेजेंट, ओम शिव प्रेजेंट, विनय बाबू प्रेजेंट, राधा प्राची कार्ला एब्सेंट, राधा मोहन प्रेजेंट।
Excuse me, sir.
Yes.
Excuse me. Sir, Pratibha has just texted me before 5 minutes she has left because the data pack was over for today since we had classes from morning. So she has said that mark are present.
Okay. Ravindra Gupta is present, Rahul Kumawat. Okay, Rajan present, Ramanpreet present, Raminder Deep present. जिसकी हो रही है वो जा सकते हैं, दूसरे क्लास ज्वाइन कर सकते हैं। Ratan is present, Ali Khurshid is absent,